So yeah, so today is we're gonna work through a Excel problem. There is a data set. It's called the um, it's called the malpractice data set. Essentially, it has information um, on different lawyers, different surgeons. What is their specialty? Are they private? What is their age? What is the severity of the malpractice and stuff like that? Are they insured or not? Um, so this is the data set you have. Okay, so objectives: practice using Excel for basic statistical analysis. I think it'll be helpful for solving the homework problems as well. And then process the data and we analyze the data set we have. Um, the data set we are going to work with is the medical malpractice data set. When I post the slides, you can go to this link. Control click. Um, and you'll see that the data set is in a GitHub for one of the past TAs. You can copy paste this data set into Excel. You can save this as a CSV and then load it into Excel if you want to replicate the results. Okay. So here, data is the malpractice data set. Black, it's not visible. So let's look at each of the variables we have, right? So just to see what kind of variables we have. So what is the first one? Amount. What kind of a variable is this? The amount of money that the doctors are making. Yes. Numerical, yes, and it's continuous or discrete. Continuous, right? Yeah. So amount. So let me write. So let me make a new tab. So the amount is continuous numerical. And what about severity of the malpractice they have? So what kind of a variable this might be? The second column. Let me see if I can make this larger. It will be categorical, yes, because the second column, this one, it's giving you what sort of severe malpractice they have done on a scale of maybe 1 to 10. 10, if the doctor has a severity of 10, it means, you know, they are pretty, they have not performed well because there are 10 options. Um, it's like giving a 5-star review. You could either give 1, 2, 3, 4, 5, right? So something like that. So it's a categorical variable. Um, and severity is a ordinal variable. So you can order the severity, right? So 0 being the less and 10 being the highest. So numerical, continuous for amount. This is ordinal, categorical. What about the third one, age? Uh, not. Uh-huh. Yeah, I mean, if you divide age into different sections from 0 to 10 and 10 to 20, 10, 20, 30, then you can make it categorical like that. But just for this example, it will be a numerical continuous. Okay. Uh, yeah. So amount, and age, they are continuous variables. Okay. What about the private attorney? What kind of a variable will this be? Categorical, right? And will it be nominal or ordinal? Nominal, right? Because you cannot order them. Nominal. Marital status, categorical. And just to be specific, nominal, right? No. Ordinal means you can order, they have a natural order to them. Nominal means you cannot order them. Okay. Specialty, specialty, what what they focus on, will be a categorical variable as well, right? Um, can you order them? Mm, not really, right? You cannot say pediatrics is higher than internal medicine or something. There's no natural order to it. That's what I mean. So this is also nominal. So you'll see most of the variables are categorical in nature, except for amount and age. Pretty much everything should be categorical, right? Insurance is what kind of insurance they have is also categorical nominal. Um, and what kind of gender they are is also nominal categorical. So this is the data set at a glance, right? So what sort of variables are there in the data set. You know what kind of variables they are, and you also know the bigger picture. That is, what is this data set about? So once you know all of these things, we can use Excel to see some graphs, to see some summary statistics, and stuff like that. So once you load the data set, it'll look like this. Um, so each column is a variable, and there are around 118 entries. Okay, so there are 118 subjects. So the first thing that we are doing is getting a summary statistics. And this is the step you need to follow if you're not familiar with Excel. Okay, so first what you do is you go to files. So you have to install something called analysis toolpack and analysis toolpack VBA, these two things. Okay, the way to do it is you go to Excel, you go to file here, you go to options all the way on the bottom. You go to add-ins, then you go to analysis, you click on the analysis toolpack, you hit go, and you select both the analysis toolpack and analysis toolpack VBA. Okay. Do you guys know how to do this? It's taught. Okay. So is this clear? How to do this? You go to file, you go all the way up to the option menu. You go to add-ins, and then you add the two analysis toolpack and analysis toolpack VBA. You need this for the data analysis. Okay. So once you do that, what do you do now to get a summary statistics? First of all, what is a summary statistics? What sort of things comes into your mind when you hear summary statistics? standard deviation is also. So basically what it means is for every variable, you can express that variable with a single number, right? With a mean, with a median, with a standard deviation, with a range. So all of those things summarizes that variable, and those things are called summary statistics. And you can have a summary statistics for each one of the variables. Okay. Now let's do it for amount. Let's see what sort of summary statistics we get for amount. So after you install that package, what you do is you go to data on the top. After you click on data, you go all the way to the right, click on data analysis. Then it'll give you a bunch of options what you want to do, and you click on summary statistics. Where is Oh, sorry, descriptive statistics. Same thing, okay? Descriptive summary, same thing. Click on OK. Then after you click OK, you have to give what column you want the descriptive statistics for, right? So you want it for the amount. So for the amount, you go from A column, second row, all the way to A column, 119 row, okay? So these slides will be shared with you. So it's everything is written in detail what I have just done, A19. Okay, so A2, A19, yes. So you tell the Excel what column you're interested in, and basically by doing this, I'm selecting the first column. And then you click on summary statistics, and you click on where you want the output to be displayed. Okay, and I want it displayed on M98. Is this clear? Any question with this? Given the instructions on how to do what we log in Excel, we have. Yeah, you'll be, well, I'm explaining to you right now, and you'll also have this PowerPoint shared with you, right? So it has all the steps, what to do, how to install the add-ins, how to go on about your summary statistics. So this will be shared with you. Yeah. Uh, just for like a few assignments, and I don't think it's for like maybe homework 4 or 5, like 1 or 2 assignments. Yeah. Um. So yeah, once you do this, you'll see summary statistics for column 1 or let me summary statistics for amount, right? So what you have to do is just move this here, and you'll see that the mean amount of money that somebody earns is around 90,000 if they practice medicine. So it has pretty much all of the information you need. Okay, the standard error, the median, the mode, the standard deviation, the skewness, the range, maximum, minimum, count, everything. So this, once you know how to do this, you can do it for every column essentially, and it'll give you all of the information that you need for that variable. So any question up to now? No, right? The main caveat is to just have this package in Excel, and after that, I think you guys should be good. Now comes histograms. Summary statistics is a way to summarize the variable, and histogram is another way to do that, right? It's a visualization tool that tells you the distribution of your data set. So how do you plot the histogram? You do the same thing that you did. You go to data on the top, you go to data analysis, you click on histogram, click OK, you select the column that you want the histogram for. So this is A2 all the way up to A119. So we want the histogram for the amount, um, P98, and then mm, you specify where you want the output, you hit OK, then you'll see that you should see the output somewhere. Here. Then change the topic histogram for amount. So what I did is I went to the data analysis thing to create the this to create this bins. And then I went to then I went to insert recommended charts. So and then histogram. Okay. So this is the histogram for the amount column, and something similar like this. It should be plotted. Should be. Yeah. And now, what can you say about this histogram? Okay, there's an outlier. What did you say? Skewed. Yes. Um, so the two observations are skewed and outlier, right? So which might be an outlier? On the this one. Why do you think this one is an outlier? True. What? How would you identify outliers? Um, if I give you, let's say, 1, 2, 3, 4, 5, and 100. Let's say this is my data. One, so it has 6 observations: 1, 2, 3, 4, 5, and 100. Okay, what would be an outlier here on this data set? 100, right? Um, so think of it like this. Outlier is a point which does not belong to where most of your data is concentrated. Okay, it's very far off from where most of your data is concentrated. So this will not be an outlier in this case. This is where all your data set is basically being concentrated, right? Because this represents different levels of income that every individual earns, and this is the highest. So this data has a distribution like this essentially. Okay, it's a right skewed distribution, and your outlier would be a point somewhere here. Okay, this will be an outlier. Does that make sense? Let me give an like a more um, okay. So let's say, so just focusing on the topic of outliers. Okay, let's say your histogram looks like this. What sort of a distribution this histogram has? A symmetric distribution, right? So where is most of the data concentrated? In the middle, right? So where will be the outlier? Probably be outside on the tails, right? Probably an outlier will be here, somewhere here. Um, you can, if you want to be more realistic, let's say this is the height. This is the average is 5.5, and the observations like 4 feet and 6.9s are outliers, right? Most of the people in your data set have a height of 5.5, and some people have 4.0, some people have 6.9. So they will be mostly be outliers, probably. What about this? If your histogram looks like this, what sort of a distribution is this? Left skewed, right? It has a tail towards the left, so left skewed. So where is the most of the data concentrated here? The right here, right? Bulk of the data is here, and um, if there is an outlier, it will probably be somewhere here, right? Somewhere in this direction. And the same goes for that example that we're doing. It's a right skewed, so this is left skewed. If there is an outlier, it will probably be here. Probably is what I'm using, okay? And this is a Gaussian or a symmetric distribution. And this is a right skewed distribution. And if there is an outlier, it will probably be somewhere here, right? So this is clear, right? Yeah. And if there's an outlier, it'll probably be here. Yeah. Um, Outlier is any data point that does not fit the narrative of the entire data set. Something is off, something does not belong to a distribution. Those things are outliers. And we will see box plots are the best way to find outliers. Have you guys been taught box plots? No? Yeah? Okay, we'll go over box plots, okay? Um, but yeah, this is a right skew distribution. Where did that go? Yeah, what can we say about the histogram? It's a right skewed. It's a right skewed. Um, oh, give me a sec. Okay, the computer froze. Okay. Go to okay. Where were we? Okay. Symmetric or skewed? Skewed towards the right. What can we say about the mean and the median? Which one is higher? So, so where's the mean, median, and mode for a symmetric distribution? All in the center, right? So this 5.5 is everything, mean, median, mode. What about if it is left skewed? The mean is lower than median, yes. Um, see if I can find a better picture. Okay, so yes. So yeah, when it is symmetric, everything is in the center. When it is left skewed, the mean is shifted towards the direction of the outlier. Okay, so you can make this large. Okay, here the mean. If you see the third picture, that's a left skewed distribution, right? Your mean is highly affected by outliers. Okay, and your mean is shifted in the direction of wherever your outlier is. In this left skewed distribution, your outliers will probably be in the left side, right? So the mean is shifted towards the left. You'll see in a right skewed distribution, the mean is shifted towards the right. Okay, so that's like a basic rule of thumb. Mean is affected by outliers. So the mean, so this will be the mean, and this will be your median, right? Mean is less than the median. What about here? This will be the mean and a median will be somewhere here, right? So mean is greater than median. Is this clear? Yeah. And the reason it happens, I think it's a, sorry. The reason, this example is pretty good. The example that I was giving, so let's say your data is 1, 2, 3, 4, 5, and 100, right? What is the median? What is the median of this data set? Let me do this, okay? So let me remove the 100 from here. 5 observations. Where is the median? 3. What is the mean? It's 6 plus 10 plus 15. 15 divided by 5, right? 3. And the mode, there is no mode. Every number is unique. Now this is a pretty nice data set. What happens when you add a outlier to it? The median will also shift, yeah, but not as much as the mean. You'll see so what is the median here? 3.5, and the mean is now definitely more than 3, right? It's 115 by 3. Sorry, 115 by 5. Uh, oh, sorry, yeah, 6. 6. And it's whatever this division is, okay? It's definitely greater than 3. So you see that, when you add an outlier to your data set, when you add an outlier, the median does not shift much, but the mean shifts in the direction of the outlier, right? So if your data was negative 100, 1, 2, 3, 4, 5. Now the mean will be a negative number, right? Negative something. So you see the mean is going towards 100. For the third data set, the mean is going towards the negative 100. So that's sort of a logic that we follow in all of these cases. The mean is being pulled. Um, what about the spread of the data set? What about the spread of this data set? What tells you about the spread of the data set? What quantity tells you how much spread your data set is? Have you guys been taught standard deviation? Okay, okay. So let me go over that because it'll be taught. How do I state this? Okay. Um, whenever you see a data set, there's a measure of there are two things you have to keep in mind. What is a measure of central tendency? What do I mean by this is what information will give you information about the center of your data set. So what might be those things? Any guesses? The median is one. What about the mean? Does that tell you where the center of the data set is? Uh, yeah, right? It does. And median also does. So all of those three things, mean, median, and mode, tells you where your center of the data set is or gives you some idea about your center. Now, measure of spread is tells you how spread your data set is from the center, right? So since you guys have not been taught that, it's standard deviation. It's range and something called interquartile range, IQR. Okay. So these three things, just like mean, median, and mode, will tell you how much your data set is spread. And the main one is standard deviation. For example, look at this, right? So this is the center. This is the center. This is histogram 1. This is histogram 2. So which has a greater standard deviation, or you think? Maybe let me draw it in a more nice way. Okay, so it's clear. One of the histograms looks like this, and the other histograms looks like this. So which one will have a higher standard deviation? No. Yes. Why do you think the second one has a higher standard deviation? It's more spread out, right? So that's what we are looking at, is a measure of spread. It's like how spread your data set are from where most of your data is concentrated. You'll see that this is not that spread from the center, but this is pretty spread. So standard deviation of this guy, let's say standard deviation 1, this is standard deviation 2. Standard deviation 2 will be greater than standard deviation 1, right? So these things are important to know. What tells you about the center? What tells you about the spread? Uh, and which one to choose actually is also important. Do you use, is it a good idea to now look, where did I draw that picture? Now for a symmetric distribution, right? You want to find out the measure center. You could use median, mean, and mode. Any of them is fine. 3 is fine. But what about a left or right skewed distribution? What measure of center is better to use when the distribution has outliers? Out of these 3 things, mean, median, and mode, what will be a good center? The mean, but the mean is affected by the outlier, right? The the median is a good measure of center, right? Because you can look for this data set. The median is 3.5. It tells you where the center is, but the mean does not help us, right? When the data is pretty symmetric like this, then you can use mean, median both. Do you get the idea? So you have to look at the data set, and then you have to say, okay, my data set is skewed. It has outliers, so I cannot use mean as a measure of center because it will give me a wrong center. I need to use median. So when and you have to do the same thing for a measure of spread. Um, we'll talk about that later, okay? But yeah, coming back to, where was I? Okay, here. Standard deviation. High standard deviation indicates that the data is spread out. A standard deviation close to 0 means that data is concentrated around the mean. Okay, so that's the basic idea, is how much spread your data set is, the standard deviation tells you.
Can we just calculate that by looking at the histogram, or do we have to calculate like the average,
Uh-huh.
like number wise?
Uh, you can you can get a sense of what you need to use by just looking at the histograms. You No, you cannot get a sense of the exact number, but you can get a sense of, is it larger, it is smaller, compared. If you have to compare two histograms, then you don't need to calculate, right? If I give you these two histograms in exams and say which one has a higher standard deviation, without giving you anything, any data at all, yeah, then you will say which one, the second one is the highest, right? Um, so yeah, things like these. Um, so okay, the next one is the box plot. So what we're doing in this session is we had a data set. We looked at each of the variables, saw what kind of variables they were. We plotted the descriptive statistics. We did the summary statistics that gives you the mean, median, and mode for all of these things. We saw the distribution of the data set for that variable, for the first variable, and now we are doing a box plot, okay? To do a box plot, what you need to do is you go to insert, go to recommended charts, and go to all charts, and you can select which chart you want, and I want a box plot here. Okay. Mm, sorry, it's not working, not working. First, you have to select the column. Okay, sorry. You have to select this column. Then go to insert, go to recommended charts, then go to all charts, box and whiskers, and here's your box plot. Go this here. Yeah. Box plot of amount variable. So first, let me tell you what a box plot does, and then we'll go see what sort of a box plot we have. Okay. So let me add a new blank. Okay. So first tell me, what does a histogram tell you about a data set? When you plot a histogram, you look at it, what information does it give you? Yeah, but for that, you could look at the summary statistics as well, right? You don't need to plot the histogram. Yes. Yeah. It tells you about the distribution of your data set, right? If it is symmetric, left skewed or right skewed. Now, the box plot does the same thing, kind of the same thing. Uh, Box plots, just like histograms, tells you um, about the distribution of a data set. Yeah. Um, to understand box plots, you have to understand these three things first. What is Q1, Q2, Q3? These three things comes into box plots. Okay, Q1 is point such that so these three are points that divide the data set into different percentage halves. Look at this data set. One, two, let me draw here, 3, 4, 5. Now, what is the point that, let's find Q2 in this data set, okay? What is the point such that it divides the data set in 50-50? 3, right? And this 3 is also called the median, right? Um, so Q2 is also called the median. It's another name for Q2 is the median. Now, what about Q1? Uh, so so if this is your if 3 is your Q2, then this means this is 50% of your data set, and this is 50% of your data set, right? So you need a point such that it's 25% now. So what will be Q1? Maybe I need to zoom it. See. Uh, no. So let me here. This is your Q2, right? This is 50%. This is 50%. Now you want 25%. So which one will give you 25? 2 will give you 25, right? If you divide a data set like this is this is 25, this is 25. When you add them up, this is 50%, right? So 2 is the point such that below which 25% of the data set lies. What about Q3? So this is Q1, this is Q2. What about Q3? 75%. Below that data set, below that data point is 75% of the data set. It will be 4, right? This. So these things are important. They will come into box plots, and you'll see box plots moving forward in exams and homeworks. Okay, so it's important that you know what Q1 is, what Q2 is, what Q3 is, um, what is the definition of it. Basically, the definition is not hard at all. It's just looking for points that divides your data set into certain halves. Okay, 50% up and down is your median. Q1 is 25% below that point. Q3 is 75% below that point. Okay. So once you have all of these things, you can now do a box plot. Okay. A box plot looks like this. It's basically something like this. Looks like this. Where this is your Q1, this is your Q1, this is your Q2, and this is your Q3. Okay. So for this data set, Q1 is where? Q1 is 2. So if you do it like this is 2, this is 3, this is 4, right? Um, and this is called the interquartile range that I was talking about, the measure of spread. One is standard deviation, one is also interquartile range, okay? So just like when you had an outlier, you could not use the mean as a measure of central tendency. You needed to use the median, right? When you have an outlier, you cannot use standard deviation as a measure of spread. You need to use the interquartile range, which is this range, IQR. IQR is Q3 minus Q1, right? So what is the length of this thing? 2, right? 4 minus 2 is 2. Is this clear? And there are two important things. I know this stuff is new for you guys, but it'll be useful. Okay, so this is called the lower whisker, and this is called the upper whisker. It's Q3 plus 1.5 times the IQR. It's Q1 minus 1.5 times the IQR. So what is the upper whisker based on this formula? So it's 4 plus 1.5 times 2, 7, right? Yeah. So Q3 is 4 plus 1.5 times IQR is 2. So 2 times 1.5 is 3. 3 plus 4 is 7. So this point here is 7. What about this point? What is this point? Q1, what is Q1? 2 minus 1.5 times 2, 2 minus 3, it's negative 1, right? This is a box plot in a nutshell. You find your quartiles. These Q1, Q2, Q3 are called quartiles, okay? You find your quartiles, you find your upper and your lower whisker, um, and then voila, you have a box plot. Now, why do we need a box plot when there is histograms, right? You already have a way to visualize your data set. Why do we need to do all of this? The main reason is that in histograms, outliers are not easily identified. You cannot say, okay, this is an outlier right off the top. But in box plots, you can. If this is a box plot, any points that are below the lower whisker and any points that are above the upper whisker are called outliers. So these are outliers. It's super easy to identify outliers, okay? These are also outliers. This is your Q2, it gives you the center, this gives you the 25% mark, this gives you the 75% mark, and as a whole, it represents, gives you a sort of visual representation of the data set with a clear understanding of the outliers, okay? Now, this can also be represented in a vertical fashion. So you'll see, so don't get confused when you see a box plot like this. Same thing, okay? This is your Q1, this is your lower whisker, this is your Q2, Q3, and upper whisker. Okay, any questions? No? So now let's come to this amount variable, right? The amount of doctors. See if I can extend it. See, I can change the styling, make it a little more. Okay, let me stick with this. So where is your Q1? Where is your Q1? 0. Yeah, uh, it's not exactly at 0. It's this line. I don't know if you can see. It's barely visible. Okay, so this is your Q2. Your Q1 is at 0. And where is Q3? This one, right? Yeah, it's squeezed. And where's your upper and lower whisker? This is your upper whisker, right? And your lower whisker is like buried underneath. And what are these things? Outliers, right? Now let's say I don't give you a histogram. I just give you this box plot. Can you tell me what skewness it might have just based on this box plot? Right skewed. And why do you think it's right skewed without looking at the histogram? True, true. So that's another way you can identify the skewness of the distribution too, right? Because when when it's right skewed, the outliers will be greater than what most of your values are, right? And when it is left skewed, the outlier will be lesser than what most of your values are. Yeah, any question? So that's basically it for this session. Okay, identify different types of variables, plot the histo, plot the outliers, plot the box plot, and see the distribution. Understand the quartiles, see how having a left skewed or right skewed affects the thing that you choose to represent the central tendency as and a measure of spread. You stop share.